try another one here. We're going to find the 0 of this x cubed plus 2. And we know, you can see from the graph that the 0 is somewhere over here near -1. We can see that. So let's try that as our guess. Let's go in and try -1. And we'll enter it. Now I'll get back that screen. There it is. I get in my answer. That's my Newton's formula. And I press enter. Okay, and there's my first. Oh, wait a sec. I'm sorry. I was trying to use the 0 to begin with. But let's go ahead and let's do that first. Let's put the 0 in. Sorry. Okay, so 0, and then get that number back. Let me get that expression back. There it is. Okay, and now press enter. Division by 0. What happened? Well, with 0 as my first estimate, notice the derivative back in here. Back in here, the derivative. Oops. At 0 was 0. So in my formula, I'm dividing by the derivative, which is a 0, and that's where the method went off the tracks. So if that happens at some point in the iteration, then it's just bad luck, and that's why this method is not as rigorous as some of the others, because you don't want this to happen in the middle of your calculation. However, if it does, reset your initial guess, and usually you'll get around it. But let's try that. Let's go back and let's try, as I did before, let's try the -1 now. Because we see there's a 0, the method just failed on us. Okay, so do that one more time. Enter. Okay, this time we got a number. Enter again, enter again, enter again, enter again. Now you notice there's no change all the way out to that 1, 2, 3, 4, 5, 6, 7, 8th decimal place. So you're pretty much done at this point. The difference between two successive approximations is to the, what is it, 10 millionth, 1 tenths, hundreds, thousands, 10,000s, 100,000s, millions. I mean, that's out to like billionth decimal place. So it's fine. Now, what would happen if you picked, let's say, the number 2 as your estimate? It's way over here. Let's see what would happen there. Let's get that expression back up there again. That one, and let's enter. It brought me down closer. I overshot, but if I keep pressing enter, it is getting me closer and closer. Maybe not as quickly as my other estimate, but there it is. I'm back again. So that was just bad luck that I ended up with a 0 as in my derivative. In other words, my x sub n was my first x sub n, was x sub 1 after my initial guess, was a 0, and I had a 0 slope right there. So anyway, so that's the moral of the story. Just try it again if you end up with a 0 as a derivative in the method. So we're okay, back on track. So we got our answer for this one. Let's see, -1.25992105.